So in these questions, we're going to be using Kepler's third law to calculate the period of an orbiting object. So the mean radius and period of the planet Saturn are 9.5 astronomical units and 29.5 years respectively. The mean orbit radius of Uranus is 30.1 astronomical units. Calculate its period. So to do this, we're going to use the fact that the t squared divided by r cubed equals a constant for two bodies that are orbiting the same object. And because we're looking at planets for our solar system here, Saturn and Uranus, they're both orbiting the Sun, and so therefore we know that they will have the same constant. In fact, the constant will be very close to 1, because that's what we use, but where we've got rounded numbers it'll be a bit of a difference, so let's work it out. So for Saturn, working it out for Saturn, to work out k, we're going to use the t squared. So the t squared is the time, so 29.5 squared, the years, divided by the astronomical units radius at 9.5 cubed, which equals 1.015017. So that is our value for k. So therefore we can work out for Uranus, we know that t squared over r cubed, this is for Uranus now, so t squared, that's what we're trying to work out. We're trying to work out the period, so t divided by the radius, 30.1 cubed, is going to equal the same constant, so 1.015017 that we found out here. So we can rearrange this equation by bringing 30.1 cubed over the side, so multiplying it, which gives us 27,680.4 blah blah blah. But we don't want that, we want t. So to work out t, we're going to have to square root that number, and if we do that, we find it's 166.3. So we know that the period of Uranus is around about 166.3 years, because it will be the same as what's ever in the question. Okay, similar question to the one before. The mean radius and period of the planet Mars are 1.52 astronomical units and 1.88 years respectively, and the mean orbit radius of Venus is 0.72, so calculate its period. So again, we're going to work out t squared over r cubed to get k, the constant. So if we do that for Mars, we're going to do 1.88 squared, that's the time, divided by 1.52 cubed, which gives us 1.006432. So that's our value of k. And then for Venus, very similarly, we know that t squared divided by r cubed, 0.72, equals the value of k that we got before, so 1.006432. So we know that t squared equals this number multiplied by 0.72 cubed, which is 0.375649. So to get t, we need to square root that. Square root, and that gives us 0.1612902, something like that. So to give it a sensible answer, 0.612902, to give it a sensible answer, it's going to be around about 0.61 years. So in this question, we're trying to work out the orbital period of Ganymede. So to do this, we've got all the details for Carpo, another moon of Jupiter. So again, we can work out t squared over r cubed to give us the k, the constant. So the orbital period is 458.6 days. So we square that, divide it by the orbital radius, which is 17.14 cubed, gives us a constant of 41.767 approximately. And so therefore we know that for Ganymede, t squared, which is what we're trying to find out, divided by r cubed, 1.07 cubed, equals the same constant that we just worked out, so 41.767. So to bring 1.07 cubed to this side, we just multiply it, so t squared is equivalent to 51.16, and so to get t, we literally need to square root that, which gives us 7.15. So we know that The orbital period of Ganymede is 7.15 days, because it's the same as what was in the table. Okay, lastly, our last question, the trickier one, isn't that tricky. The only difference we need to notice is that we've got kilometres and metres. So for meters, we will convert it into kilometres. We divide by 1,000, so we can just knock off the last 3 zeros. So that'll be 127,690 kilometres. And then we can do exactly the same thing. So we're going to work out the t squared over r cubed for Metis. So 7.07 squared divided by 127,690 cubed. That gives us 2.4 times 10 to the minus 18. Because they're both orbiting, they're both moons of Jupiter, therefore Thebe will have t squared over r cubed, so 221,889 cubed will equal the same constant, so 2.4 times 10 to the minus 18. So to bring this over there, you're going to multiply them, which gives us t squared a value of 262.286, and we just want t, so we need to square root that number, which comes into around about 16.19 days.